What's going on, Logan? So we're going to take some notes today. Please open your notebooks, to page 38. Go ahead and label the page 38 and label it as parallel lines. At any point in time, if you feel it necessary to pause this video, please pause the video. Allow yourself to take the notes or to do the problems. I gotta stress, don't just copy what I write. If I ask you to do a problem, pause it, try to do the problem, and then watch the rest of the video. But make sure that you're pausing throughout. If you need to rewind, rewind. But this should not be you watch it once and that's it. You can kind of go at your own pace, speed it up, slow it down. The first thing I'd like to do is take a look at this first question. This first question right here, what I'd like you to do is graph both of these equations. So you're going to graph the first equation right here, graph the second equation on the same exact graph, and then answer these two questions. Number one, what do these equations have in common? Followed by, how would you describe these lines? Go ahead and pause the video right now. Give yourself a chance to write in your notebook these things and then to graph them and answer these questions. So I'll wait for you. When you're ready, go ahead and press play and we'll talk about the answers. Alright, so you've had a chance to graph it. Hopefully you've paused, and if you haven't, do it so now, and then go through the problems. The first thing I'd like you guys to understand is that when you graph this right here, just use slope-intercept. So I'm going to graph this guy over here in red. I'm going to start at -7, because that's the y-intercept, and I'm going to go up 3 over 2. So up 3 and across 2. I'm going to keep doing this until I have no more points. So up 3, 1, 2, 3, and over 2. Up 3 again, 1, 2, 3, and over 2. Now I notice that I'm going to fall out of points. I'm going to miss points right here. So I'm going to go ahead and start graphing now. So I'm going to connect my 4 points, and I get that line. Next, I'm going to graph the second equation. I'm going to do this one in this weird-looking blueberry blue color. I'm going to start at 1. So we start over here at 1, but now we're going to go up 3 still and over 2. Up 3, 1, 2, 3, and also over 2. Now you'll notice I ran out of points, so I can go in the opposite direction. So down 3, 1, 2, 3, and over 2, making sure that I do continue to draw a line. Down 3 and over 2. It doesn't look like I can fit any more points, so I'm going to go ahead and connect those guys right there. So we'll connect those points and answer the questions that was asked of us. What do these equations have in common? We'll take a look at these equations. You'll notice that they're both in slope-intercept form. They also have the same exact slope. So you could say y equals mx plus b is one thing they have in common, y equals mx plus b. That's a more structural thing that they have in common. But more importantly is actually the slopes. The slopes are the same. So what do they have in common? Same slopes. So I'm going to write same slopes. And then go ahead and answer question number 2. How would you describe these lines? Now hopefully you already answered these questions, and it looks like these lines, very similar to the title of the section, these lines look parallel. Now, before we go any further, what we'd like to do is define these definitions, define these words. So what I'd like you to do is take the notes for the following. Go ahead and scroll to the second part. I would suggest going 14s. So draw lines at every 14. Draw lines at every 14. If you need to go back and redo the problem, go back and redo the problem. All right, so parallel lines. Parallel lines are two lines that will never intersect no matter how long you draw the lines. Remember that. No matter how long these lines are, they're never going to cross each other. So if you had infinite amount of time and you draw these lines forever, they never cross. Now, the question here that I have to ask you, that you also have an answer available to yourselves, is how do you think someone can tell if lines will be parallel just by looking at the two equations? So let's go back to the two equations we were looking at. How could you tell that those two lines were parallel without drawing those lines? Well, one option is to take a look at the slopes. The answer is that the slopes will be exactly the same. Keep that in mind. If you need more time to write more notes, please pause the video. If you don't, go on to the next section. The next section, what I'd like you to do is I want you to find which of the following are parallel. Using what we just said, parallel lines have the same exact slopes. Which of these, A, B, C, D, E, and F, which of these are parallel? So go ahead and pause the video, and then we'll talk about which ones are parallel. Welcome back. Hopefully you've had a chance to go ahead and identify all the parallel lines. Now remember, we said that parallel lines have the same exact slope. So on this problem, on problem A, I noticed that my slope is 3/4. But when I look at all of these, none of them match. All right, so that means this one doesn't match any of them. However, when you look at B and C, you'll notice that they have the same exact slope. So my first answer is that B and C are parallel lines. So we know that B and C are parallel lines. But you'll notice that in B and C, you also have D as y equals -4/3. It looks really close, but it's not exactly the same. That negative means that they're different. Now you also have E and F. So what I'd like you to do is look at the slopes for E and F. So for E, take any 2 points. I'm going to take that point right there and that point right there. And I'm just going to count to get the slope. So I'm going to rise 1, 2, 3. So we went up 3, so it's a plus 3. Let me darken that with some black on there. So plus 3. And then across this way, 1, 2, 3, 4. That's plus 4. That tells me that my slope is plus 3 over plus 4. Now you'll notice that this slope right here matches A. So now I can say that A and E have parallel lines or parallel slopes. So A and E are parallel as well. So I've taken care of A and E. Now obviously D and F look like they're going to be the same because they're the last guy standing, but let's prove it. Let's show why. So we're going to take a look at the slopes here. Now remember, slope is a rate of change, but it's a rate of change where you put the y change on top of the x change. So we're going to look at the y's. So 2 to 6 is plus 4, 6 to 10 is plus 4, and 10 to 14 is plus 4. If you think you know the answer, go ahead and pause the video right now and go through this problem, making sure that you understand it. Next, 8 to 5, that's minus 3, 5 to 2, minus 3, 2 to negative 1, also minus 3. You'll notice that it is a constant rate of change. That's because this is a linear function. Next, my slope is delta y, the plus 4, over delta x, the minus 3. So we got positive 4 over negative 3. What this tells me is that my last set of functions, D and F are parallel lines. Please make sure that when I talk to you guys on Wednesday, you're able to talk to me about parallel lines, how you can tell if equations are parallel. Remember, slopes will be exactly the same. Thank you, and watch the next video.